Welcome back to part 2 of Module 6, Lesson 5, Dividing Rational Numbers. Dividing equations, solving division equations. We're going to start this lesson off with a quick little video about how to solve these problems, and then we'll go back into more of the instruction.
Use bar diagrams to solve one-step division equations. Use a bar diagram to solve x divided by 4 equals 6. Draw a bar to represent the total. The total length of the bar diagram represents the dividend, x. Label the bar to show the original amount. Divide the bar into 4 sections to model the divisor. Write a 6 beneath the first box to show that when x is divided by 4, each part has a value of 6. Solve the equation. Work backward. Since x divided by 4 is 6, 6 times 4 equals x, so x equals 24. Let's try another. Use a bar diagram to solve x divided by 3 equals 7. The total length of the bar diagram represents the dividend, x. Label the bar to show the original amount. Divide the bar into 3 sections to model the divisor. Write a 7 beneath the first box to show that when x is divided by 3, each part has a value of 7. Solve the equation. Work backward. Since x divided by 3 is 7, 7 times 3 equals x, so x equals 21.
Now once again, while that's a great visual representation of how to solve your problems, it really isn't great for actually having to work these problems out by hand every day. It's very time consuming and whatnot, and it would be so much easier if we had something cool like, I don't know, maybe algebra to solve it with. And with that, we lead into the multiplication property of an equality. Very similar to the division property of an equality we did on the previous lesson, and the subtraction and addition properties of equality we've also done in this module. It says to solve the division equation, use the inverse operation, which is multiplication. And when you solve an equation by multiplying each side of the equation by the same number, you're going to be using the multiplication property of an equality. In words, the definition for that is going to be if you multiply each side of an equation by the same numbers, the two sides are going to remain equal. And looking at it with numbers and with variables, if 6 equals 6, you multiply both sides times 5, then you're going to get 30 equals 30. If x divided by 3 is equal to 4, you multiply both sides by 3. The 3's on the left are going to divide out, leaving you x is equal to 12. Very similar to the previous 3 lessons we've done. I don't think you're going to have any problem with this in the homework. And that leads us straight into example 2, which is x divided by 9 is equal to 13. And there's going to be a couple ways to solve this, I suspect. I like using algebra. Are they going to make us use a bar diagram first? Let's see what they say. No, they are not. We're going to go straight into the algebraic approach, where we have to find our variable. Our variable is x. His friend is 9. 9 is dividing each side. X is dividing, or 9 is divided on each side, so we're going to undo divided by 9 by multiplying 9 on both sides. And you can see that's exactly what they did here. They multiplied by 9 on the left, and they multiplied by 9 on the right. The 9's on the left, you're going to want to put a line through them, or better yet, a 1 through them, showing that they've divided each other out, and 1 times x is x. And on the right, 9 times 13, well, 9 times 10 is 90, 9 times 3 is 27, 90 plus 27, that's going to end up being 117, I do believe, and checks your answer. So the answer to that equation is going to be that x is equal to 117. That is showing your work. That is what I must see. If I don't see that on each and every problem of your homework, you will have done it just for fun. Alright, now it's going to be your turn. Pause the video, work this problem on your own on a sheet of paper, making sure you show good high quality supporting work as you do it. Alright, so once again, what is the final goal of any equation? It is to isolate the variable. My variable is going to be t. whoops, need my pen here. T is being divided by 7, and we're going to undo divided by 7 by multiplying 7 on both sides. I have T divided by 7 times 7 is equal to 13 times 7. Now the textbooks use parentheses. I like the multiplication dot. As long as you don't have a negative number in there, it doesn't make any difference. 7 divided by 7 is 1. 1 times T is T. 13 times 7, well, that's going to be 70 plus 21, which is going to give us 91 for our final answer. Jump back over here to the textbook, put in our 91, and hit check. The answer checks. That's all there is to do on these problems. Of course, this is showing your work. This is what I must see, and if I don't see that on each and every problem of your homework, you're doing it just for fun. But what if you had something really ugly like this one that says C divided by 3 is equal to 2/5? We're going to go about it the same exact way. Ask yourself the questions. What's the final goal of any equation? It's to isolate the variable. What's my variable? It's C. Who's C's friend? It's 3. And what is 3 doing to C? It's dividing. So how do I undo divided by 3? I multiply 3 on both sides. And that's exactly what they're going to be doing to solve this problem. Whoops, so I push the wrong button there. So you can see right here, we're going to take and multiply by 3. But they're probably going to want that to be listed as a fraction, as being 3 over 1 on the left. And we're going to multiply by 3, also known as 3 over 1 on the right. Hit check, and that checks. And the reason we did it as a fraction was because we're multiplying fractions here. Of course, from there, the 3's on the left are going to zero or divide each other out, becoming 1, and 1 times C is C. And on the right-hand side, nothing's going to simplify, so we're going to go straight into our final answer that says 2 times 3, that's going to be 6. 1 times 5 times 1, that's going to be 5. Uh-oh, that is an improper fraction. And since we have an improper fraction, I'm going to have to go back and change that to become 1 and 1/5. Hit check, accept, and check, and the answer checks. That is showing your work, folks. That is what I must see. And now you get a chance to work one of those on your own, just like I worked. So go ahead and pause the video, work this problem on your own. This one's involving decimals instead of fractions, which means you're going to need some kind of ugly grunt work off to the side. Make sure you're showing all your supporting work as you do, and I'll come back and check it with you in a minute. And it is my turn. What's the final goal of any equation? To isolate the variable. What's your variable? It's G. Who's G's friend? 2.5. And what is 2.5 doing to G? It's dividing. How do I undo divided by 2.5? By multiplying 2.5 on both sides of that equation. So my first step, get my cursor working over here. I'm not sure why I quit. Hold on. Alright, we have it going on here. So I'm going to get my pen going. 9 72/100 times 2.5 on the left is equal to G divided by 2.5 times 2.5 on the right. Now I do want to point out that 2.5 is in the top. You need to have it in the top or at least in the middle. If you end up doing this times 2.5 on the bottom where it's in line with that I'm going to have to take points off for, because that is not the proper way to show your work. So from here I can take and say that 2.5 divided by 2.5 is 1. And 1 times G is G. And then over on the left-hand side, we're going to have that grunt work of the 9 72/100 times the 2 5/10. 5 times 2 is 10. 5 times 7 is 35. Plus 1 is 36. 5 times 9 is 45. Plus 3 is going to be 48. 2 times 2 is 4. 2 times 7 is 14. 2 times 18. 2 times 9 is 18, plus 1 is going to be 19. Add those up, 0, 10, 13, and that's going to be 14 and a 2. And then we'll go 1, 2, 3, 1, 2, 3. So the answer is 24.3. So from here, we can jump back over to our textbook page, and we can type in 24.3, check, and it checks. That's it for this lesson. Make sure when you're doing your homework tonight that you are giving me good high quality supporting work just like I'm giving you. I need the good work. If I don't get it, I cannot give you credit for it. See you in class tomorrow.